Okay, everybody, really quick, good morning. I just want to go over some really important things. I think the other videos were really good. The first one where she explained why we have currents and everything like that is really good. The second one, just the general makeup of this map is pretty good. I just want to go over a couple of things which are really important. I'm just going to switch over to a color version of this one. A couple major things that hopefully you picked out on here is that we have these swirls of ocean currents, and you can see right here. We got a swirl right here. We have another swirl right here. And if you notice, mostly everything above the equator is moving, and these swirls is moving clockwise. And that's something called the Coriolis effect, which we'll get to a little bit later. Everything south of the equator is going counterclockwise in terms of their flow. I know we can pick out areas that are not, but generally when we have these areas right here, we have counterclockwise in the southern hemisphere. So what's the big deal for some of these things? I want to focus on the Gulf Stream current. And we can look at our key. It is warm. And this Gulf Stream current is like a conveyor belt, and it plays a huge role in climate and moving heat around the globe. That's one thing you got in the other video, is that this does move heat from the equator to the poles and move cold from the poles down to the equator. And one of the important kind of things to see what it does, if you look at the Gulf Stream right up here, and it goes all the way up here into Europe and Scandinavia. If we look at a place like England and Ireland, and it doesn't really snow there much. A relatively cool climate, but it does not snow. If we look at a comparable place, and I know this isn't curved, but if we go over here, it puts us into northern Canada, and it's an ice box up here, and it snows all the time for months. So the reason why England and Ireland do not have these snowy areas or climates is because this Gulf current slowly brings heat up here, and it warms the climate. And so when you have, sure, it cools as it goes up, but it actually warms it up, and so it's not as cold as it should be. So it's redistributing that heat from the equator up into this area. There's a lot of other factors, but that is one factor that it does. We can also look at another place on how currents affect the climate. If we look at Iceland right here, Iceland is not, Iceland is not always icy all year round. It has seasons. And part of that is due to the North Atlantic current, which splits up. You get the Norwegian, we get the East Greenland current. But it is pretty frosty up there. But it does have a summer. On the other hand, Greenland, literally right next door, it is cold all year round. And the reason for that is it is surrounded by these cold currents. So if somehow this warm water were to get up here, that would definitely change the climate, but it's not. Of course, we have these density differences and other factors and salinity that affect these patterns. So we can see how we get this redistribution of heat, and it can change what an area is like England, Ireland, and Iceland because of this heat moving around. The other major thing just to look at really quick, and we'll get to this in weather and other climate, is if you notice, all of our hurricanes start off as tropical storms out here off the coast of Africa. And as it makes its way across, gains strength from the ocean, and boom, it hits the Carolinas, Florida, and the Gulf. And one reason is because that's the way the currents are going. If you ever notice, California, Oregon, and Washington never have hurricanes. And that is because of this cold current right here. The system isn't set up to have hurricanes on this part of the United States, or at least the continent. We can go to the other side of the world. So here is Japan. They call them typhoons in Southeast Asia. But nonetheless, notice their hurricanes, when we get to them, actually flow in this direction. So they start off over here in the Pacific, and boom, they move up north over here. And one of the reasons, there's other reasons, but we have this general circulation of warm water, which warms the air above it, and that causes more moisture, so on and so forth. And just like you heard in the other video, you have colder water, which cools the air above it. So we have a couple features that it affects climates. Not only redistribution of heat, it can affect the climate from the currents, and there's a lot of things we can look at here. So for example, old shipping routes, whalers would leave Massachusetts off the Cape and Nantucket, and you think they want to get to the Pacific, you think they just go like this, and they wouldn't. They'd actually follow the currents this way, pick up supplies, come down this way, and then they'd cruise around here, they'd fight all this, and then get back over here. So it was a pretty lengthy way to get over to the Pacific back in the 1800s, but nonetheless, they followed these currents. Otherwise, you'd be going against the current, and then you'd have some serious problems and take a lot longer. The other thing somebody brought up is here's the international date line right across here. So if we go to the international date line, this is going to be the east, this is going to be the west, and the way I interpret the question is if you're right here on 180, if you move over to the east side, which would be over on this side, which is the east side over here, you actually is going to be a day ahead. So for example, almost, it doesn't like change every time you move across, but for example, right about now, we are kind of starting our day on Thursday, and this part of the world, if not already, is already on Friday, or at least a couple of hours from Friday. So when you move to the east side of this, well, this course is the east side, but if you go to the eastern part of the hemisphere, you're going to go ahead and you are going to be a day ahead. If you go this way, you kind of stay in the same day. So again, if someone's flying here on Friday, they'd go back over to Thursday. If you leave here on Thursday, again, it all depends on the time, you might land over here the next day. So that is what's up with this line right here, which is not exactly 180. If you actually look at it, it's all bent up. And that's just because we don't want to have part of the United States, which is these the Aleutian Islands, being on a different day than the rest of the country, which would be weird. One last thing, if we take a look at all of these things, these currents right here, we can pull together a bunch of other reference table questions. They might ask you, off the coast of South America, was it a trench? Is it a divergent boundary? What kind of current is there? What kind of rocks you're going to find? All that kind of stuff can be drawn together when we look at our reference table. So that's just really quick some of the things I wanted to point out. If you have any questions, please just let me know, and I'll talk to you later.